Okay, so we'll start a new series pseudo calculus problems. Okay, so we'll start a new series kind of pseudo calculus problems. Means if someone has lot of problem, how we can directly tackle the problem. So we have talked a lot about pseudo multivariate calculus. Pseudo multivariate calculus in the sense that how someone can proceed when he sees the problem. Okay, now we will tackle problem by problem because we have done lot of theoretical concept as far as pseudo multivariable calculus is concerned. How we start solving something. So here we will take care of the kind of differential equations also because problem comes, then problem does not see that what path we take. Problem sees that we meet the solution. If someone has problem, if someone is facing problem, then idea is that he should come to a solution quickly. Okay, in that path he may use calculus, he may use vector, he may use algebra, he may not use anything. If solution is coming merely by numerical mathematics, then why he would use these many fundamentals? Not required. Okay, so how to come to solution very quickly? Okay, I have one kind of a simple problem. What is my simple problem? What is area of a circle? I believe this is very simple question. What is area of a circle? Very simple question. What is the area of a circle? What is the area of a circle? Okay, how to calculate area of a circle? Impossible. Okay, no one can calculate area of a circle in normal mathematical fundamental. Okay, what is normal mathematical fundamental is width into height. Width into height is the area. If someone calculates width into height, then he cannot calculate the area anyway. But pseudo calculus problem idea is we start with the simple things only. We start with the simple things only. Now, how to calculate area of a circle? Okay, okay, there can be many ways calculating area of the circle. Generally, people would say that I cannot calculate area of a circle because it is very difficult. But what you can do? I can calculate area of a rectangle. That is height by width is area of a rectangle. Okay. Now, how I can tackle calculating area of circle? Okay, through the pseudo way, through the okay, through the pseudo way. Now, how I can solve this problem? What is area? What is area of a circle? Area of anything is height by width. Simple. Or length by width is area of anything. Okay, as per our way, pseudo calculus problem. How we can solve problem by problem through pseudo way. What is area of a circle? Area of a circle is same as area of a simplest case is rectangle. Length by width is area. What is length or what is height? If I say this is in xy plane, what is the height? Okay, consider length I denote it by y and this by x. Then area of a rectangle is y into x. I believe it is very simple. Y into x is area. Area of rectangle is height by width. Okay, now pseudo way means we start doing something with the simplest case. if I'm trying to calculate area of the circle, then I go by the simplest case calculating the area of a rectangle. That is length by width is area of the circle indeed. Okay, area of this rectangle. If I talk about circle, then height by width will give the area. What is height of the circle? Height of the circle is this. And what is width of the circle? Width of circle is this. If I multiply this height with width, this will give the area. This is pseudo code. Now I write area of circle is y into x. Now let's say x is this and y is this. Considering this, the center is origin. The center is origin and this is x-axis, then this is y-axis. Half of the y-axis is positive and half of the y-axis is negative. Negative y-axis. Half of the x-axis is positive and half of the x-axis is negative. Now y into x is the area. This is pseudo code. Now what is y as far as rectangle is concerned? Then y is a static number, maybe 2, 3, 4, 5, 6, 7, whatever it is. And width, that is height, width is a numeric number, just multiply it. But if I talk in circle, then height is not constant, height is variable everywhere. If I see here, the height is small. If I see here, height is bigger. If I see here, height is smaller. Means if I go along x-axis and see the height, height is varying. Means height is dependent upon x-axis. If I go along x-axis, height varies. Okay, height is dependent upon x-axis. Okay, anyway, what is the area of a circle? Area of a circle is height into width, y into x. Okay, now as per now, height is function over x because as x is changing, y is changing. Y is not a number or not a algebra also. If I say x is an algebra, y is an algebra, but it is dependent upon x. It is not independent. In that sense, I can write now function over x, small f bracket open, small x bracket close, f bracket open, x bracket close, fx. Fx into x, that is the area. Okay, but you said area of a circle, area of anything is fx into x. Okay, y into x, height into width, function over x into x. But mind it, here height is function over x, not required that in every shape height will be function over x. It may be constant. In that sense, it won't be fx, it will be something else. Then direct multiplication will give the area. But in circle, as we move along x-axis, height is changing. Means height is dependent upon x. Height is a function over x. There is a Python function called f, and parameter or argument is x. If you pass the x, it will return the height. Means depending upon the x, the height is different. If x is 0, then height is maximum. When x is a, that is the radius of circle, height is 0. So I have a function f and it takes argument as x, and then if I call this function with any x, it will return the y. If x is a, it will return 0. If x is 0, it will return a. At that time, y is maximum. But anyway, I have learned that calculating the area of any shape is height into width, because that is the simplest area for a rectangle. Now it is fx into x. If I try to multiply two items, where one item is independent component, that is x, and other item is dependent upon x, then it is fx dx. This will be, the multiplication will be transformed into integral calculus. Integral calculus means multiplication that is achieved through graphical way. If I multiply fx into x or y into x, Rather than directly going with multiplication, I go with drawing a graph where x-axis is there and y-axis is there. And then I draw a graph and then calculate area of the graph. Whatever is the area, that is multiplication. Means if I'm trying to calculate area of this circle, then it is indeed height into width. That is the area. I am really sorry. If I'm trying to calculate area, if I'm trying to calculate area of this circle, if I'm trying to calculate area of the circle, what will be the area of the circle in the simplest case? If I take a small 1 unit by 1 unit, 1 unit width, 1 unit height, one small area, 1 unit width, 1 unit height, place it inside this one by one. How many numbers you counted? It will be small. How many numbers you counted? If it is curve section, then there take even smaller. Okay, and now count how many they are. That is the area. What is area of this shape is? Area of this shape is actually if I take a 1 unit width and 1 unit height, one square, and fit it in this, then count the number of a square, and that is the area of this circle. Okay, very nice, very true. But if I'm trying to calculate multiplication of multiplication of two item, multiplication can be achieved by repeated addition, or multiplication can be achieved by drawing the graph of two item. If I'm trying to calculate y into x, I'll take x-axis and y-axis and draw the graph and then calculate the area. That is also multiplication. So if I say fx into x, then it certainly it will we cannot achieve the result with the repeated addition. If I say 5 into 4, what is 5 into 4? 5 into 4 is same as 5 plus 5 plus 5 plus 5. 5 repeated addition 4 times. If I say y into x, that is same as y plus y plus y plus y plus y plus y plus x time. This is called repeated addition. This is how multiplication works. What is 10 into 5? 50. How you know 50? I know 10 into 5 is 50. No. Actually it is 10 5 times. 10 plus 10 plus. This is one way of calculating the multiplication. Other way of calculating the multiplication is draw the graph of 10 into 5. 5 take as x-axis and 10 you take as y-axis. Now, you whatever graph comes, calculate the area of the graph, that will also give the multiplication. That is another way of that. Calculus talks about calculating multiplication through calculation of the area rather than repeated addition. This is calculus way. Repeated addition will not work if it is algebra. Multiplication is of two algebraic items and one is dependent upon other. Repeated addition fails there. But area of a graph will work there. Okay, area of a graph will work with the numeric multiplication also, and area of a graph will work for the algebraic multiplication also. Area of a graph will work with the algebraic multiplication, one independent and one is dependent everywhere. Means calculating multiplication through drawing the area of a graph and calculating the area is actually generic way of calculating the multiplication. So blindly, if I say, if I am calculating 5 into 4, then can you go with the integral calculus? Certain, we can go with the integral calculus where 5 into, instead of 4 I would say x, and then 5 into dx. Okay, in integral calculus, if I'm trying to do multiplication, and for the multiplication operator, one operand and other operand, if other operand is independent component and other operand is dependent component, then we can write something like this: fx into x will be rewritten as fx into dx. If place d there, claiming that it is integral calculus, it is not direct multiplication. If I say 5 into x, then it is direct multiplication. If I say 5 into dx, then it is not direct multiplication. Multiplication will be achieved through calculation of the area. Now go and draw the area and calculate the area. Okay, so 5 into 4 can be rewritten as 5 into x, and which can be rewritten as 5 into dx. If I change x into dx, then one limit will come into the picture. X is from where to where? 0 to 4. Dx integration is x 0 to 4. It will come as 5 into 4 only. Anyway, now when I'm trying to calculate area of a circle, fx into x, now it will become fx into dx. Fx into dx. When I change x into dx, x will show its limit. X will be from minus a to a, minus a to a. When we talk about fx, that is y, then y is, this is x axis, then y is above the x axis. We will get the top part of the circle as area. Okay, not the full. Anyway, what is fx, function over x? The circle equation is x square plus y square equal to a square. Y equal to square root of a square minus x square. So it will become a square root of a square minus x square dx. X is from minus a to a. Whatever is this integration is, that is the area of the circle top part. So if I take x equal to a cos theta, method of substitution, then dx will be a minus sine theta d theta. In that sense, it will become a square root of 1 minus cos square theta, that will be sine theta. A sine theta, and dx will be a minus sine theta d theta. A square will come out, minus will come out, sine square theta d theta. Sine square theta d theta integration is theta by 2. Theta by 2 minus sine 2 theta by 4. Theta by 2 minus sine 2 theta by 4. Now what is theta, that we have to calculate? Now when x equal to a cos theta, when x is limit is minus a, then theta is cos inverse x by a. Cos inverse minus 1 and cos inverse 1. Minus 1 is pi to 0. Okay, pi to 0, theta by 2 minus sine 2 theta by 4. That is the integration. If I take 0 as upper limit, full will be 0. Minus is outside, minus gone. Now pi we will take, it will become pi by 2. Sine 2 theta pi, it will be 0 only. Pi by 2. It will be pi a square by 2 into both side. If I take pi a square, pi a square is the area of a circle. Thank you very much. Okay, this is one way. What can be other way? Other way is that multiplication of width and height gives the area, that we learned now. If this is the width and this is the height, it gives the area. If this is origin and this point is x comma y, x1 comma y1, and this point is x2 comma y2, then multiplication of x1 whole square plus y1 whole square root. This is the length of this part. If this point is x1 y1, origin 0 comma 0, and y x2 y2, then it will become x1 whole square plus x2 whole square into, I'm sorry, x1 whole square plus y1 whole square root into x2 whole square plus y2 whole square root. Now this will be the area. The first one is magnitude of a vector, and that is x1i plus y1j magnitude into magnitude of another vector x2i plus y2j magnitude. Okay, if that is the case, x1i plus y1j is the magnitude cross product x2i plus y2j magnitude. If these two cross product if I take, then it becomes the area of this. Okay, now consider this vector I am taking is a vector. A vector is x1i plus y1j, and this is b vector, that is x2i plus y2j. In that case, it becomes magnitude of A into magnitude of B will give the area of this surface. Or in bigger term, if I say, then A cross B, A is a vector, A cross B, whatever comes, magnitude of that will give the area. That is called area vector. A cross B is area vector. Area vector magnitude will give the area of the surface. Okay, in that sense, area vector A is x1I plus y1j cross product with x2I plus y2j. These two cross product will give the area vector. Anyway, now in the previous series we talked about pseudo multivariate calculus. In pseudo multivariate, that consider that this surface we are talking here, the surface we are talking here, that is A cross B, where A is a vector representation of a straight line and B is vector representation of a straight line. There is no straight line, there is a curved line. What is the vector representation of a curved line? Straight line is xi plus yj connecting 0, 0 to x, y. If I have a curved line that is also connecting 0, 0 to x, y, but that will not be a straight line. That will not be a straight line. Straight line is this is a straight line connecting origin and x, y is xi plus yj. If this is not a straight line connecting origin and x, y, what is the vector representation of this curved line? Okay, then vector representation of this curved line is still xi plus yj. But y by x should be there because y by x, if this is x-axis and this is y-axis, this is x-axis and this is y-axis. Y by x, y by x, y by x, everywhere it is variable. It is different for the curved line. Means whatever representation I make for the vector of a straight line, it should have y by x because that is variable. Now if I take out x, then it becomes I plus y by xj into x. This here y by x is there. This is the vector representation of a curved line. Make sense? Okay, this is the vector representation of a curved line. In that sense, now we have, if I say that A cross B is the area calculation, A is x1I plus y1j cross product with x2I plus y2j. Now from one side I'll take out x and other side I will take out y. I can take out anything. Okay, in that sense, I am making y as variable in other side and x as variable on this side. Now it will become, now forget x1, y1 and x2, y2. Let's talk in x only. 1 will become I plus y by xj bracket close into x cross product with j plus y by, sorry, x by yi plus j bracket close into y. Now division will become differentiation and multiplication will become integration as per we talked about big concept we gave. Now it will become I plus dy by dxj bracket close into dx cross product with j dx by dy I dx by dy I plus j bracket close into dy. If these two vectors, if I take cross product, then probably it will give the area. Okay, in that sense, it will come as I plus dy by dx cross dx by dy I plus j vector dx dy. This will give the area vector. Okay, this will give the area. Anyway, we are proceeding in a very heavy discussion how to calculate the area. Anyway, now if I talk about this vector cross product to calculate the area, vector cross product to calculate the area. Okay, now in that way we have I plus dy by dx bracket close cross product dx by dy I plus j bracket close dx dy. Now when we have dx dy, it talks about a surface where one is x and one is y. When there are two in dx dy, there are two independent components here, dx dy, but that is not true. When we talk about circle, there is only one independent component, that is x-axis. y-axis is dependent upon x. dx dy, if I say, then x is independent and y is independent. Okay, in that way, this will not work. But we want to compute the surface area of a circle through vector, where x is independent and y is independent. Is it really possible? It is possible. If we consider three dimension, if we talk about three dimension, then it is possible. Three dimension, I want area in two dimension. What is three dimension? Consider there is a z also, where z is 1, and calculate the volume. If I have a base as circle and height as 1, that will make a cylinder. Base is a circle and height is, and there is a height all around, it will form a cylinder. Height is 1. Consider height is 1. Calculating the volume of a cylinder, calculating the volume of a cylinder is the area of the circle. Makes sense? That is also true. Calculating the volume of a circle will give the area, volume of the volume of a cylinder will give the area. Okay, anyway, now that is another way we will proceed upon. Anyway, let's proceed. Okay, what is the concept that we are, okay, let's proceed. Okay, we have so many ways calculating the area of a circle. Now, if I do in that fashion, if I do in that fashion, then what will be the area of a circle? Okay, if I do in that fashion, then if I have three dimension, where this is the base and this is the height, this is the base and this is the height. Okay, what is the area of this base? What is the area of this base? Area of this base is I have taken I plus dy by dxj, cross product dx by dy I plus j dx dy. Now, if I take in three dimension, where height is 1, and base is xy plane, then x and y are independent to each other. Okay, in that fashion, dy by dx will be 0, though it is not 0. dy by dx is there. Y equal to square root of a square minus x square, that is a circle equation. But dy by dx will be d of square root of a square minus x square by dx. It will not be 0, but I have taken three dimension now, where x axis and y axis are xy plane and they are independent to each other. Height is dependent upon x and y. If that is the case, then our area vector is, now we are trying to calculate the area. Area vector is I, but we went to three dimension. Anyway, the area vector is A vector cross B vector. A vector is xi plus yj cross xi plus yj. In A vector, I took out x. I can take out anything. There I took out y to make it a vector representing the curved line. If vector represent a curved line, then there should be y by x or x y y. Then only it will represent the curved line. Then it becomes I plus dy by dx j, cross product with dx by dy I plus j dx dy. Now dy by dx is 0, because I have taken three dimension where x and y are independent to each other. They fall in xy plane. dy by dx is 0. dx, but this explanation is not available in any of the book. Anyone one can try. dy by dx is 0 and dx by dy is 0. It becomes I cross j. It becomes k vector. K unit vector dx dy is the area vector. Area vector into the height. Area vector into the height is the net volume, and height is 1. So we will, at the end, we will calculate area vector only. Height is zk. Z is 1, k. So area vector is k dx dy, and height is 1 k unit vector. Z is 1 into k unit vector, dot product with k unit vector dx dy. Now the volume calculation will come as k dot k is 1. dx dy. Dx dy integration over the xy plane. Integration over the xy plane will give the area vector. Okay, now it came as double single integration over circular region on xy plane dx dy will give the area. Actually, we are trying to calculate the volume where height is 1. In that sense, at the end, we will end up calculating the surface area of a circle. Now, if that is the case, then what will happen now? dy dx dy integration over a circular region. Now, if I dissociate the circular region, circular region means there will be x and y both. Means it will start with 0 minus a comma 0, that is a y. Then it will go till 0 comma a. Then it will go a comma 0. Then it will go uh, 0 comma minus a, then it will come back to minus a comma 0. This reason we have to do integration. Someone can divide it into two parts at least. Now this integration is minus a comma 0 or four parts, minus a comma 0 to 0 comma a dx dy plus 4 times. Someone can try. No one stops anyone. Okay, that is the scenario. Someone can try it. Or if I break this limit into dual x limit and y limit, then x is from minus a to a. X is from minus a to a. And y is minus a to a? No. Y, when I set the limit as a circular, when circle comes into the picture, then y is dependent upon x. Then x will be minus a to a and y will be minus square root of a square minus x square to square root of a square minus x square. It will give the full circle area. Y is minus square root of a square minus x square to square root of a square minus x square. X is minus a. Or someone is very curious, then he can say y is minus a to a, then x is minus square root of a square minus y square to square root of a square minus x square, whatever comes to someone's mind. Anyway, now if I take the first one, then dy I have to integrate first. Dy will become y minus square root of a square minus x square to square root of a square minus x square. Now it will become 2 square root of a square minus x square. 2 I can keep outside, and a square root of a square minus x square dx. X is minus a to a. It came to the first one only we calculated as pi a square by 2. 2 gone. Pi a square is the surface area of a circle. We will proceed on this. Life is not that simple. This is the second way of calculating the surface area of a circle through vector way and in three-dimensional cylindrical coordinate system. It will not halt here only. We will see more bumps here. Okay, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.